Everyone, Vin here, and welcome to the 2024 June Algebra 1 Regents Review. And here we go. Yes, live in New York City. Yep, we are live in New York City, coming from Staten Island, New York. So we are the Forgotten Borough. I made a nice sign for my shirt because this is one of the most popular questions that I get, and I don't see why people keep asking it unless it's people trolling. But this is not the questions for tomorrow. Okay, I am not going to do something that crazy. Even if this is not the questions for tomorrow. We'll just leave it at that. All right, I didn't take it from the mailman or nothing like that. Nothing crazy. Okay, but I just want to say good luck to everybody tomorrow. I know people are nervous, but look, just do your best to learn as much as you can from now till then. The only thing I ask of all of you is just be nice to each other in the chat. Be nice, I guess, to me. I know people are excited, whatever, but just, keep it real in the chat. I give like one heads up and then, I mute people. So, all right. But hello to everybody. Alrighty. I will talk about the new topics. So people were asking me about the new topics for the test. So let me just see real quick okay. Now I'm gonna do like an actual Regents once again. So let me just actually take this one out. I think, this is the one in PDF form. This one here. Okay. So I mean, there's a lot that's the same, but they're chopping out some of the stuff here. Like if we look, explaining why the sum or product of two rational numbers is rational. They're chopping out the explain part, but they do want you to know operations with radicals. And I put this in the description also if you want to get a copy of this. So then using units. So, I mean, here, this is just, like the stuff here that they're either chopping and removing. But looking at this, I would just say here, we'll just practice this Regents and, do the best we can with that. I didn't have time to like create my own Regents because, I mean, I just have never created my own Regents yet. But, we'll look at some good questions, though, for sure. All right. I would just say, though, like, try not to panic too much. Just learn as much math as you can from now till then and hope for the best. All right. Cool. So we will just get moving here because we have a lot of questions to cover. And all right. So first up, and let me just make sure I have the chat visible here. I do want to, be able to talk to people. And wow, 380 people already on. Just thank you so much for the support. I really do appreciate you all. Alrighty. So let's see here. The owner of a small computer repair business has one employee who is paid, here we go, an hourly rate of $22. Okay, let me just make sure this is, so that doesn't take up the whole screen. So that's their hourly rate, how much they're paid per hour. And the owner estimates his weekly profit using this function here. In this function, x represents the number of. So for this one here, if you just think about this, they just told us that the employee makes $22 per hour. And it makes sense then that we have minus 22x because we have to pay the employee. Okay, let's pretend we're the owner of the repair business. The employee has to be paid, so this subtracts from the profit. Okay, and the key word here is that this was let's just make sure this stands out, the hourly rate. So when you think about this, what this value x represents is the number of hours worked per week. Okay, because it's an hourly rate, it's based on how many hours the employee works. All right, so the more hours they work, the more we have to pay them, and the less our profit is. So that's the name of the game. If you want to use a calculator here, you can, but I wouldn't say it's like really that necessary to explore this anymore. I mean, if you really wanted to, you could go to y equals and go 8,600 and then minus 22x. You do get a calculator for the whole test, which is cool. And you're like, oh no, I can't see anything. You press second graph and go to the table. And if the employee works no hours, then $8,600. We get all the profit. But then as they work more, then we get less profit, which this isn't really realistic. I don't know, a small computer repair business and they make $7,700 a week. Like, sign me up. That's really high pay. Let's see. Let's say the employee works 40 hours, unless there's a lot of them. Yeah, I feel like they really didn't. They just kind of threw this question together in like 52 weeks. So $400,000 a year at a small, I don't know. What would you all say? Cap? But whatever. It doesn't. We're not writing the question here. So hours per week. Per week is what we're talking about. Alrighty. Next up. So unit conversion. So Peyton is a sprinter. He could run the 40-yard dash in 4.5 seconds. He converts his speed into miles per hour, as shown below. Which ratio is incorrectly written to convert his speed? All right, now the idea with this, when you multiply, so I'm going to do something easy first. So the easy version of this, and I throw this example at students all the time. They're like they say the answer quickly. So they go like, all right, how tall? I say, how tall am I in inches? And what's it called? If I ask how tall am I in inches, they say, oh, times 12. But it's like, no, I'm doing times 12 inches over 1 foot. Since 12 inches equals a foot, what we could do is just multiply like this, and these cancel out, and we're going to get 72 inches like that. Okay, so that's like an easy one. So here, when we multiply by 3 feet over 1 yard, like this is correct. We want yards to cancel. But then this is the one that's incorrect. When we multiply by this, see how feet over feet doesn't cancel. We would have feet times feet is feet squared. So right away, I could see this is the bad one. All right, but the other ones here would have been fine. If this was flipped, then everything would work out here. So right away, I could see that this is the culprit. The reason why these are fine is that minutes over minutes cancel. And then if this were done correctly, we have seconds over seconds canceling. And see how we would be left with miles per hour if this one was flipped. Okay, so this one in purple is the problem. All right, so we want the units here and here. All right. Make sure calculators are, I saw something about calculators. Wait. Yeah, use a calculator on the Regents for sure. And make sure that they are something. All right. Cool. Moving on. Which equation has the same solutions as? All right. So I'm going to show you 2 ways to do this. Like the algebra way, and then the, like, I just want to get this right and move on to the next question way. So algebra, but you can use a calculator. But if you do want to see the algebra, because this is the algebra Regents, this is called the AC method. So when you use the AC method, you multiply the A and the C term. The A term is 2, and the C term is -3. In this case, we get -6. And then our B term is the coefficient of X is 1. So now we have to come up with 2 numbers that have a product of -6 and a sum of 1. And if you think about the numbers for a moment, that's going to be 3 and -2. And now we use the AC method. We have 2x squared. But then instead of 1x, we're going to rewrite 1x as 3x minus 2x. Okay, so this is the algebra way, but I'll show you the calculator magic in a moment. And now equals 0. Okay, so I'm just rewriting the middle. And now you would do factoring by grouping. So you take out an x. If you divide these 2 by x, you get 2x plus 3. Now you could factor out a -1. Okay, the reason why I factor out a -1 is I want this and this to match. If I divide by -1, I get 2x plus 3. And this is equal to 0. So now the 2x plus 3's match. We could take it out. We're going to have 2x plus 3 times x minus 1. So question 3 should be choice 4. Now, let's say you're like, oh no, I don't like the AC method. For this, if you want to use a calculator. So let's say you're like, no, thank you. I am not doing algebra. I want to do this in the calculator. Then you're going to go to the y equals, and you're going to write in the original expression or equation, 2x squared plus x, and then -3. Okay, and then I just write all the answers. And let's say I write all of it until I get to choice 4. I get to 2x plus 3. Oh, why did I use the 2015 Regents? Because my logic behind that is I think most teachers, when they review Regents in class, are going to do the ones that are most current. So I go far back just because most people probably haven't practiced these. So, yeah. Alrighty. So press graph and see they overlap each other. All right. If I press second graph, you can see all the values match. So that's how I know 4 is good. If I type in one of the wrong answers, like let's say I type in choice 1. Choice 1 is wrong. Okay, 2x minus 1 times x plus 3. See how it misses? So like that's how I know that one's no good. Cool. Oh, let's see. Is someone not behaving in the chat? All right. Yeah, remember people, the one rule all I care about is keep it real in the chat. If I have to, I will mute people and then you lose your chat privileges. All right, so be nice to each other. That's all I care about. Alrighty, Crystal was given $3,000 when she turned 2, and her parents invested 2%. Invested it at 2% compounded annually, and no deposits or withdrawals were made. Which expression can be used to determine how much money Crystal had when she turned 18? Okay, so the formula here is this one. The 1 plus or minus r to the t power. So in this case here, it's going to be plus because it's an interest rate and the account is growing. You know, if you're investing, you're going to hope your money's not shrinking. That would be depressing. So here, A equals the principal is 3,000. And then 1 plus 2% just, oh, cool. They all say 0.02, but 2% is 2 out of 100, which is 0.02. Okay, so this is 1 plus 0.02. But now be careful. You might just be like, oh, 18. But this account started when she was 2. And we want to know at 18. So 18 minus 2. That means 16 years is going by. Okay, so just be careful here. Like this answer choice, like, LOL, don't choose this one. All right, that's a trap. If I had my bear ready, I would cue the bear sound for the bear trap. But yeah. All right. Oh no, I know a lot of people are saying that they're cooked, but just hang in there, practice. Okay. I know what cooked means. And cooking means that you're really in the zone. I'm finally learning the lingo, and then next year is going to be a whole new set of words. No, we're all going to, you're not all cooked. I would say you're all going to do the cooking. Yeah, I'm not leaking the, oh, see? Sign. I don't know if it's like a running joke, but. All right. What is the table of values? Well, I'm sorry, which table of values represents a linear relationship? So when I hear a linear relationship, I'm looking for a constant rate of change. All right, that's what we want, constant rate of change. So here, notice they're all going up by 1, the x's. See, plus 1, plus 1, plus 1. So everything there is cool. But this one goes plus 1, but then it goes plus 3. To get from -2 to 1, you're going plus 3. So this is not constant. Constant rate of change means it changes by the same amount. This is changing by different amounts. So this one's out. And this one I could tell is no good. To get from a half to 1, that's going forward a half. But then we go forward 1, not constant. So that one's out. This one's looking good. To get from here to here, go plus 2. -3 plus 2 is -1. Go plus 2 again, you get to 1. Plus 2 again. So here's our constant rate of change, which is linear. All right, this one is no good. Plus 1, plus 1. Here we go. Plus 7. That one's too much. All right, so 5 is choice 3. A mixture problem. If you could put like a sample one in the chat. All right, let's see. Let's see. Which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? Oh, okay. So if we had a function here like x and y, and we're predicting the number of household online devices. So I'll just say like number of devices. And this is like number of people in the house. All right, well, for this one, you can't have like a fraction of a person in the house. You can't have like pi people in the house. Okay. Wait, I'm gonna hang on a sec. Is there a way to, let's see. Yeah. Okay, cool. Yeah, if people are just typing in silliness, they're gonna get muted. So one down. All right. So this one, number of people can't be fractions, and you can't have negative people. All right. Like, yeah, they could maybe have like a bad attitude. But no, like every person counts. Can't have like -3 people in the house. Like people used to live there and then they don't live there anymore. That doesn't make sense. So it has to be whole numbers. Cool. Alrighty. So moving on. Let's see. The inequality is equivalent to. So this one, we'll just do the algebra. So for this one, I'll write over here 7 minus 2/3 x is less than x minus 8. Now, if you're happy with moving things to the right side, then go ahead. But I'll move the x to the left because all of the answers, the x's are on the left. So if we look at this part coming up, let's just see. We can go minus x on both sides, and we could go minus 7 on both sides. So I'm going to go minus 7 to move this piece over. Okay, and I'll just do it step by step. I won't rush. So I have this is less than x minus 15. Okay, -8 minus 7 is minus 15. And now I go minus x. And look, if you have to at any point, let's say you're like, oh no, -2/3 minus 1. I don't like fractions. Well, you could do -2/3 and then minus 1. Okay, and press math, enter, enter. See, and you get -5/3. So you could always like do the fraction stuff in the calculator and things will be fine. Okay, less than -15. If you really had to, though, -2/3 minus 1 is the same thing as -2/3 minus 3/3, which is -5/3. Okay, that's where it's coming from. So now we divide by -5/3, but you got to be very, very, very careful here. When you multiply or divide an inequality by a negative, the sign flips. Okay, so now we're doing -15 over -5/3. And for this one, we'll just go ahead and use the calculator. So watch this. Press alpha y equals enter. And it pulls up a blank fraction. So -15 and then -5/3 on bottom. It's going to give you 9. So x is greater than 9. Okay. So 7 is 1. If you want to do that by hand, just do keep, change, flip. Do -15 times, and then you flip this 3 over -5. A negative times a negative is a positive. So this is 15 times 3/5. And then 15 divided by 5 is 3. And 3 times 3 is 9. Okay, so if you want to do that by hand, you could do it by hand too. All right, cool. All right, let's see. So moving on, question 8. So the value in dollars v of x of a certain car after x years is represented by the equation given here. And we want to know to the nearest dollar, how much more is the car worth after 2 years than after 3 years? So for this one, pay attention to what the function is saying here. The value in dollars of a certain car after X years. So they want to know how much more is it worth after 2 years than after 3 years. It makes sense that it's going to be worth more 2 years because when you buy a car, it goes down in value. Like unless you're famous and people just want to buy your car because you're famous. That's why here the exponent term, the 0.86 is between 0 and 1, is going to make this shrink. It's going to be dropping down. Okay, but this is something, honestly, we just do it all in the calculator. So for this one, it's going to go to the y equals. And I'm going to type in, so let me just clear out the stuff from before. And let's see. 25,000 times 0.086 to the power x. And I put too many zeros. Definitely don't want to make a typo. Okay, we'll press delete. And now I hit second graph to go to the table. And you see, like, let me scroll back up. After 2 years is here, and after 3 years is here. So we just have to subtract these two. But I'm going to show you a nice trick. If I go to the main screen, I'm going to show you alpha trace y1. So the function we wrote in y1, and if I do parentheses 2, this is going to find the function value at 2. See that value in the table at 2? See, that's how you get it on the main screen. It's just a nice trick that you might not know. So little shortcuts. So I could do the function value at 2 minus the function value at 3 to see how much more do we have at 2 years than at 3 years. We're just subtracting those. All right, and we get this. All right, so that's our approach to this. All right, so this one, if we see here, the function value at 3 minus the function value at 2 is equal to 2588 point, my bad, got stuck, 0.6. So 0.6 tells us to round this to the nearest whole number to 2589. Okay. Cool. All right. So let's move on now. Uh-oh. Oh, I gotta put people in timeout here. Here, timeout. Yeah, if you're just gonna spam the chat, you're gonna get put in timeout. So, yeah, please don't spam. Because if people have questions and you just like hog up the chat, I mean, I could put a timer on in the chat. So, yeah. All right. So moving on. So let's see. Which function has the same y-intercept as the graph below? So here, the y-intercept is where the graph crosses the y-axis. And here it's at -3. So the next thing you got to know is y equals mx plus b. When you have the equation of a line in this form, the m value is your slope. And the b value is the y-intercept. Okay, so that's like just some really, really important stuff that you got to know. Okay. So here, let's just see. The y-intercept for, oh, there it is right there. It looks like 9 is just going to be 4. So if I have y plus 3 equals 6x, I'm going to subtract 3 on both sides. And y equals 6x minus 3. Okay, and notice the y-intercept is also -3. The reason why it's not the other answer choices, like if I had to run through all of these, well, this one, I could split this up and say 12 over 4. So for choice 1, it's y equals 12 divided by 4 minus 6x over 4. And that would give me y equals, I could reduce that to -3 over 2 times x, and then plus 12 divided by 4 is 3. So this would have a y-intercept, a b value of 3, not -3. So like that's why that's out. So if you do that for the other answer choices, you're going to get the same idea. Okay? Cool. All right, hang on. Don't worry. Wait, I clicked on the wrong person. Hang on a sec. Here we go. There we go. All right, sorry. This is like a little... Okay, so moving on. Yeah, no, I'm trying to... yeah, I got Raphael muted, so... All right, cool. Yeah, some light trolling is fine, but like if you just spam the chat. Please consider not. All right. Okay, moving on. So question 10. Let me just see. I'll do this. Give me one. Here. There we go. All right. So moving on here. Yeah, I put slow mode on. So you can send a message every 20 seconds. That's much better. And that way it's easier for me to mute people if they want to send silly things in. All right, cool. No, this is like almost every live stream. I mean, I'll take it as a compliment. 500 plus people on here. Some people are just going to come here to like, be silly. So, all right. Fred is given a rectangular piece of paper. If the length of the paper is represented by this and this, then the paper has a total area represented by. So for this one, area of a rectangle is length times width. Okay, so that's the formula. Alrighty, that is the formula that we need. So then what we're going to do is we're going to multiply the length and the width. We're going to do 2x minus 6 times 3x minus 5 equals 2x times 3x is 6x squared. Then we get minus 10x. Then we get minus 18x. And we get plus 30. Okay, so 10 here is looking like 2. Because when we combine these two, we're getting 6x squared minus 28x plus 30. Okay? Cool. So, yeah, this one's just 2. If you want to, though, once again, like there's a bunch of questions in algebra that you can just use the calculator for. Like you could go, let's see, 2x minus 6 times 3x minus 5. And then you could just run through the answer choices and see it's 6x squared minus 28x plus 30. So 1, 2, that's definitely the answer. Right? Second graph, and they all match. All right, so moving on. The graph of a line, the graph of a linear equation contains these points. Which point also lies on the graph? So a little trick. If you don't feel like writing the equation of the line yourself, that's going to take work. You can just go to the calculator, and here's a nice trick. Those 2 points, I'm going to go to Stats, Edit, and I'm going to type in 3, 11, and then we have negative 2, 1. Okay, so negative 2 and 1. All right, so there they are. And then Stats, calculate linear regression. So if you want to just come up with the equation of a line in the multiple choice, you could just use this trick. All right, you can do the algebra yourself, or I think equations of lines, like you do that in algebra, but you could also, you also do that again in geometry next year. All right, so there's your equation. So then what I have is I have y equals 2x plus 5. If I just plug in. If I want to do this myself, like I don't want to use the calculator at all, it's going to take a lot of time. I mean, I got to do the slope formula. And I would just do like, all right, m equals, and let's say this is x1, y1. And then this one is x2, y2. So if I use the formula, I get 1 minus 11 over negative 2 minus 3. And I get negative 10 over negative 5, which is positive 2. And then I have to use the mx plus b formula or the point slope form equation, but that's why it's just easier to do this. And now once I have y equals 2x plus 5, now I could just go here and write it in. All right, let's see, 2x plus 5. 2x plus 5 We go second graph. And now let's look. All of the x values are 2. And when x is 2, y should be equal to 9. Okay, so it's got to be 4. You want to be like double check, just plug in here. Like if this is x and y and you plug in, you're going to get 9 equals 2 times 2 plus 5, which is definitely a true statement. All right. Let's just see. So moving on. So, all right. Question 12. Oh, thank you for the tip. Thank you so much. And an ice cream cone. Go ice cream. All right. How does the graph of f of x compare to the graph of g of x? So this one, once again, you get a calculator. So if you forget the rules, like I'm thinking like, oh, replacing x with -2 moves it to the right 2 units. +1 goes up. So it's right and up. So I know like just from that, it's like going to be one of these. And then multiplying by 3 makes your graph narrower. So like just knowing the concepts will get you here. But let's say you're like, oh no, I don't know the rules. If you have a calculator, like just like use it, you know, like x squared is here. And then the next function, f of x, I'll write in the next line, is 3 times x minus 2 squared, and then +1. Okay, so we graph this, and you see how this one is to the right 2, up 1? So see, we're going right 2, up 1 to get from blue to red. Just follow the vertex, right 2, up 1. And this graph is definitely narrower. It got skinnier. It's increasing faster because of this scale factor here. Okay, so 12 is 2. All right, next up. Connor is at a town festival, and the price of admission is this. This is the fixed amount. So he just pays that fee once, and then each ride costs this much. So this is like the rate here. Where my head goes is like y equals mx plus b. And we say slope y-intercept, but in word problems, it's the rate. So this is the rate, and this is the fixed amount. Okay, so this is the fixed amount. So then here, if I have to set this up, the variable here, r, is the number of rides. So the r is going to be attached to the rate, and the rate is 79 cents. So it's going to be 0.79 r, and then plus the fixed amount is 450. So just looking at this, I could see these answers. I don't know what on earth just happened. Okay, let's try that again. All right, so this one's out, this one's out. See how the r has to be attached to the 79 cents. So that's why here. And let's just see. What we want, though, is this to be less than or equal to 16. So sometimes on the Regents, they'll just be like, hey, is it less than or greater than? It would have to be less than, because you have to, like, you can't have your money exceed $16. If that's the most you could spend, then you can't spend more than that. Okay. So then from here, now we just solve the inequality. So minus 450. And this is like just like annoying subtraction. So I'll just, that's 1150 though. So let me just type it out. Save. Yeah, 1150. So 1150 less than or equal to 0.79 times r. So now we just divide by 0.79. And r is less than or equal to. So now this divided by 0.79 is going to give us 14.55. And I'll stop here at 7. Okay. Now, be careful here. People might look at this and go, 15, let me round to the biggest number. But no, think about it. In this world, everything costs money. And if you are like, hey, I want to buy something, and they're like, all right, it costs this many dollars, and you don't have enough money, they're going to turn you away. So if you want to go to an amusement park and you're paying for each ride, you can't say like, let me take the 15th ride, but then like halfway through, just like I'm going to leave the ride. I'm just going to climb down. Like, no, that's insane. Okay. You would need like 15 or more to be able to pay for that 15th ride. So this case here, it's like a real world situation that we're rounding down, even though that's a 5. So just be careful, all right? So yeah, 13 is 3. Okay, Corinne is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. All right, I don't know who ever thinks about that when they choose their vacation, but whatever. So she constructed box plots shown which destination has a median. Here's the important stuff. So a median temperature above 80 and the smallest interquartile range. So if we want to answer this one, we have to know the anatomy of a box and whisker plot. So here, this one is our Q1. Q2 is known as your median. And then Q3 is here. And then like that's the end here, like Q4. So this is like the max and the min value. Okay, but see how it's like 1, 2, 3, 4 quarters. So the interquartile range is Q3 minus Q1. Okay, so that's something to look at. But this line here, that's your median. So if the first requirement is the median is above 80, then Serene Shores is out because that line is less than 80. And then Ocean Beach is out. But now it's between Whispering Palms and Pelican Beach. But this one has a small interquartile range. You see how interquartile range is Q3 minus Q1. So we want that space to be as small as possible, which Pelican Beach it is. See how this interquartile range is wider. So that's why it's just choice 4. Alrighty? Cool. So moving on. So let's see, question 15. Let's see. Some banks charge a fee on savings accounts that are left inactive. Yeah, sadly, that's true. And the equation here represents the value y of one account that was left inactive for a period of X years. That was a water bottle. I just got to... Oh, here it is, right next to me. So let's see. What is the y-intercept? Well, if we graph this, because if you really know your exponential functions, like, honestly, the y-intercept happens when x is 0. So I'm just imagining here, our graph is going to look something, fix that, is going to look something like this. Okay, so it's starting off at 5,000. And then it's decreasing. Now, I guess in the context of the question, like we're not going to go back in time. We're going to start here at 0. So it's exponential decay like this. So the y-intercept here is 5,000, and that's the amount of money in the account initially. Now, if you're like, wait, how did you do that without a calculator? It's just experience working with exponential functions. The coefficient here is the y-intercept. So if we were to write this in, 5,000 times 0.98 to the x goes here. And then I graph this. I'm like, oh no, I can't see anything. Well, that's because if you go to the table, you see how it starts at 5,000. So I would need my window to go up to, let's say I go up to 8,000. I'm going to put my y maximum at 8,000. Now I could see something. Okay, so the y-intercept is where x is 0, and the y-intercept is 5,000. So if you think about this, if we're looking at this here, 5,000 represents the starting amount of money, and then the money in the account is dropping. Okay, so that's the idea. The equation represents the value of one account. So the value is how much money it has. The y value is the money. Here, what this means is that if you think of the formula A equals P 1 plus or minus R to the T, this tells me that R is equal to 0.02, which is the same thing as 2%. So they're taking away 2% every year if you don't use your bank account, which is kind of a lot. You know, this is not, I feel like this is not really realistic. But whatever, I guess that's banks for you. All right, so yeah, that one's choice 3. Literal equations, I think I saw that somewhere in the chat. So let's see. And let me just see. All right. So we have the volume of a cylinder formula. The positive value of R in terms of H and V is. So we're looking for the positive value of R. We're solving for the variable R. All right. So that's this piece here. And it's hard to draw that small. So here, what makes this topic a little tricky, like I just remember students complaining about this, is the variable that you're solving for, like when you do the algebra, the stuff is not canceling out. Like when I divide both sides by pi, like yes, it cancels out on the right side, but all it did is move to the left side. Okay, like this. So just move to the left. And now equals r squared h. So here, if I divide, the next step would be divide by h. I'm going to divide this side by h, which means it's going to go in the denominator. Like that. Okay, so now I'm here, r squared equals v over pi h. And we take the square root of both sides. And since r is positive, I'm not going to say plus or minus. I'm just going to say r equals radical v over pi h. So 16 is 1. Okay? Cool. Which equation has the same solutions as this one? So if you really had to use the calculator, you could just make all of these say 0, like subtract 2, and so on. I'll show you how to do that after. But this one, I guess if we had to, we could use completing the square, because completing the square has potential to show up. So here, I'll start by going plus 7 on both sides. And now I'm going to have x squared plus 6x, and then blank equals 7. The concept of completing the square that we need is we're taking the b term, we're dividing by 2 and squaring it. Okay, so we're going to do 6 divided by 2 squared, which is equal to 9, and we're adding that to both sides. So now the left side factors nicely. We need two numbers that have a sum of 6 and a product of 9. And the numbers are 3 and 3. So I get x plus 3 times x plus 3 equals 7 plus 9. And now this is just x plus 3 squared. So this question, I guess the intention was like, oh, do completing the square. But it is a Regents and you get a calculator and this is multiple choice. You can do this. Okay, this is like the emergency. Like, oh no, I don't want to complete the square. I just want to get this right. So if you make this equal 0 as well, now you could just graph this left side and this left side and see that they match. All right, let's see. So I'm going to go to y equals. And we've got x plus 3 squared minus 16. Whoops, not 2, minus 16. And then the original was x squared plus 6x minus 7. Oh, zoom 6. Zoom 6 puts the calculator back to normal, and notice they match. So our math works. All right, let's see. I like to think everybody here is going to do the cooking. All right, that's what I want to see. Okay, so here we have these two functions are graphed on the same set of axes, and we want to know which statement is true about the solution. All right, so this one you could use a calculator once again. The only thing is this one we have to solve it for y. That's a line in standard form. So 3x plus 3y equals 27. So we could start by going minus 3x on both sides. Now be careful here. Students get really tripped up with this kind of stuff. This is now 3y equals negative 3x, but then that's a positive 27. If you want to say 27 minus 3x, it's fine. But now I'm going to divide everything by 3. So y equals negative x, and then plus 9. So now I could graph absolute value x minus 3 and this one and see what happens. So let's see. Absolute value x minus 3. I press math. Go to the right. I have absolute value x minus 3. And this is negative x plus 9. And this is going to have only one solution. This is more of a geometry concept, but since like absolute value is really like, if we look here, see how the slope x minus 3 is 1, but this one here is reflected. So it has the slope of negative 1. And the slope of negative 1 matches this slope of negative 1. So the red and the blue are parallel for this part. So these will never intersect. But the only point of intersection is going to be here. And I can just press second trace 5 and then scroll up to the intersection. And let's see, moment of truth. Enter 3 times, it's 6, 3. Okay, so the solution is going to be 6, 3. So just this one. All right, it's the only one that satisfies both. All of those are extras. All right, yeah, a solution to a system of equations has to satisfy all of the equations, not at least one. So 4, the reasoning is just out. All right, so this one here, let's see. The algebra that jumps out at me is this rule. But you have a calculator, so you can brute force this and just plug in. All right, so here, they're telling us Miriam uses the function this, Jessica uses this function. N represents the initial number of bacteria, and T is the time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve? All right, so if Miriam gets 16 bacteria, so Miriam uses this one, and Jessica uses this function, and we want to know how many should Jessica start with. So for Miriam, we're saying if N is the number of bacteria and she starts with 16, then for Miriam, we're going to have f of t equals 16 to the 2t power. Now, if you want to do this without a calculator, the trick is knowing this rule. That I could rewrite as 16 to the second to the t. So I'm like using this rule, but backwards. And then 16 times 16 is 256 to the t power. Now, if we look at Jessica's formula, so Jessica, g of t is equal to n to the 4t. But this we could say is n to the 4th to the t power. So what we really need to happen here is we need n to the 4th to be equal to 256. So if n to the 4th is equal to 256, and we want to solve for n, the opposite of power 4 is 4th root, which the calculator will tell us. In this case, I think it's 4. 19, yeah, it's 4. Okay, but look, let's say you just want to brute force this. You can. All you got to do, if you just want to do this like, just quickly, is type in 16 to the 2t, or 2x. And then you just run through the answer choices. See how it's like n to the 4t? So if you try out 4 to the 4x, and then you go to the table, see here, like they all match. So you're like, cool, there's my answer. All right, so that works too. Recursive sequences. Let me just see. Is this one of those topics that they got rid of? Let me just see. I think this might be... create blah, blah, blah. They might have gotten rid of recursive. Let's just see this, blah, blah, blah. Yeah, because this year I didn't teach algebra. I taught geometry and AP calculus, BC. I don't know. Why am I getting a feeling that this might not be anymore? Oh, wait. Recognize that sequences are functions sometimes defined recursively, whose domain is a subset All right, let's just see, because this is the new stuff and this is the old stuff. Are they saying that the recursive is out? I think they are. I mean, whatever. I guess we'll just kind of blast from the past, talk about it. But really all the recursive sequence is it's defined by, it's defined by the previous term. Okay, so defined by the previous. Okay, so here, if I'm starting at f of 0, if I plug in n equals 0, this is f of 0 plus 1 equals -2 times f of 0 plus 3. So I'm just plugging in n equals 0. And that gives me f of 1 is equal to -2 f of 0 plus 3. So f of 1 equals -2. F of 0 is 2 plus 3. So they start us off. They have to give you like a starting point. And then -4 plus 3 is -1. So now that you know what f of 1 is, now you could plug in n equals 1. And this is going to give you f of 1 plus 1, which is equal to -2 times f of 1 plus 3. So you see I'm just plugging in n equals 1 now. And that tells me f of 2 equals -2 times f of 1 is -1 plus 3. And then 2 plus 3 is 5. Okay, so like that's, if your teacher taught that, then cool. But I don't know, that's saying that they chopped it. So cool. All right, moving on. An astronaut drops a rock off the edge of a cliff on the moon. Very cool. The distance that it travels in meters after t seconds can be modeled by this function here. What is the average speed in meters per second of the rock between 5 and 10 seconds? So average rate of change. I just think of this formula, f of b minus f of a over b minus a. Okay, so that's the one I'm thinking of. And then from here, we're using the function d of t. So we're going to find d of 10 minus d of 5 over 10 minus 5. And the way I know to use this is because d of 10, d of t is in meters, and t is in seconds. So you see we get that meters per second that we need. Okay, so now I could just use the calculator for this. All right, so we can just plug this in. So maybe I'll just go ahead and do that. So we have y equals, and we've got 0.8 times x squared. And from here, I'm press alpha y equals enter. That's going to pull up a blank fraction. And now I just type in the function at 10. I'm going to press alpha trace y1 at 10. I can take this. I think we will get it, right? This is not tomorrow's test. Watch, that's like the first question people ask now. Whoops, wrong button. All right, so y of 10 minus y of 5. So alpha trace y1, 5. And I'll pretend I don't know 10 minus 5 is 5. And we get 12. Okay, so the answer here is 12. 21 is 1. If you want to solve it by hand, you can, but like you have a calculator, so like why do that? Like, you say, oh, d of 10 is 0.8 times 10 squared. And then order of operations, this is 0.8 times parentheses exponents. 10 squared is 100, and 80% of 100 is 80. Okay, so like that would start to give you all of these values. If you take 80% of 25, that's 20. And then you get 60 divided by 5 is 12. Okay, so that's how you do. Yeah, if you want to do it by hand, but you have a calculator, so I would use the calculator for that, just to be safe. Okay. So let's just see. So moving on, when factored completely. All right, so factored completely, we're going to use a difference of two squares. So let me just make that a little neater. A squared minus b squared factors nicely to a plus b times a minus b. All right. Let me just see. Is someone being not nice? Let me just see. All right. All right, cool. Yeah, remember, more silence if you're just going to spam and say not nice things. Okay, moving on. So here, p to the fourth minus 81. So in my head, the math that I'm doing is I'm taking square roots in my head. Square root of p to the fourth is p squared. Okay, and the square root of 81 is 9. So when we start this off, plus minus, that's how it's starting. It's like you're doing the square root of the first thing, plus or minus the square root of the second thing. So the square root of p to the 4 is p to the second. And the square root of 81 is 9. But if you stop here, like this, just be careful. All right, if I had my bear with me, I would have the bear roar at people. All right. When they say factor completely, that means you're probably going to have to do two things. Like try, and in this one, we could factor again. So p squared plus 9 is a sum of two squares. We can't factor that. But this one factors to p plus 3 times p minus 3. I'm saying the square root of p squared for this question is p, and the square root of 9 is 3. All right, so this one factors once more to this. So 22 is 3. All right, 2 more to go. And this one is a good question. All right, this one has like a bit of a trap to it. So for this one, this is the equation of a line, the point slope form equation, which is actually going to help a lot here. So the United States Postal Service charges 46 cents to mail a letter weighing up to 1 ounce. And then after 1 ounce, it's 20 cents per ounce for each additional ounce. Which function would determine the cost, C of Z, in mailing a letter weighing Z ounces? Now, for this one, what you want to do is you just have to think very carefully about this. That whatever is like actually happening here. So for this one, what we have is this thing is really like the action is starting at 1. Okay. For 1 ounce, it's like 46 cents. All right. So 46, 46. And then this thing starts to take off for everything after. So what is the cost for an integer greater than 1? Because between 0 and 1, the cost is just 46 cents. So like we're really just trying to come up with what is the equation of this line. So what we have to know here is the slope, and then we could plug into this. We already know that this line is starting at the point 1, 0.46. Okay, this is like our x1, y1. And our slope is the 20 cents per ounce. So now we just plug into the formula. We have 0.20, x minus 1, and we have y minus 0.46 equals. And now to solve for y, I just go plus 0.46. So y equals 0.20 times x minus 1 plus 0.46. And that's matching this one. Okay. Now look, one thing you could also do that eliminates everything. For greater than, like, where z is an integer greater than 1. So if you have z and c of z, you could just start plugging in numbers. Say like, all right, well, at 1, 2, 3, and so on. And say for 1 ounce, it's 46 cents. But then every ounce after that, it's another 20 cents. So this would be 66, and then 86, and so on. So if you just plugged in 1 for everything, so times 1, like this, the only one of these that's going to start you at 46. So yeah, this would give you like 46 cents plus 20 cents is 66. 20 plus 46 is 66. And then this one cancels. The only one that gives you 46 cents is the last answer choice. All right, so that's why also it has to be 4. All right. Moving on. All right, last question for the multiple choice. So let's see, what are they asking? Polynomial contains factors, blah, blah, blah. Okay, so factors, this is the big idea. That's most likely going to be on this Regents. Big idea is factors and roots have an opposite relationship. Okay, factors and roots have an opposite relationship. Okay, so here, when I see the factors like x times x minus 2 times x plus 5, and I set those factors equal to 0, this one I just set x equal to 0, and I'm like, all right, there's one root. If I set x minus 2 equal to 0, the root is opposite of minus 2, the factor. It's going to give me x equals positive 2. I just do plus 2 on both sides, I get this. And then x plus 5 equals 0 gives me x equals negative 5. So I'm looking for something that has roots, 3 roots, 0 to negative 5. So 0, see this one's missing a 2, so this one's out. 0 to negative 1, 2, 3, 4, 5. This is looking good. Okay, this one's good. This one's no good. 2 and negative 5, it needs a root at 0. It's missing 1. Okay, so 1 only. Alrighty. So that is the way. Cool. All right, how we all doing out there? I hope everyone's moving on. All right. Oh, at Stream Fame Clips. Yeah, so I showed this earlier, but yeah, alpha. Wait, would you say alpha and the variable button? Oh, Stream Fame Clip. Thank you so much. I did not know that. So thank you. Yeah, I'm a big fan of giving credit where it's due, but that's pretty cool. Yeah, just alpha X. You alpha, yeah, so you just saved me 50% of my time. I appreciate you so much. Thank you. So yeah, just checking out the chat because I've been talking for a while. So all right, this is the stuff now. They're gonna make you do more operations with radicals. So I don't know, like the new Regents, you got to know how to add, multiply, subtract, divide. So stuff like that. Show us some cheats. Yeah, I mean the calculator. How could I pass the Regents with the calculator only? That is a great question. So, oh, the y2 minus y1 thing. Yeah, I mean, look, to be honest, if you got so good with the calculator that you're able to pass with just the calculator, the irony is like you probably wouldn't even need the calculator. Like you really, like the calculator, it's like Thor's hammer, right? That only Thor could hold it, and then finally Captain America could hold it. Like you gotta like level up yourself, and then you'll really be able to hold that thing. So yeah, it's like kind of like, not that I'm like on Thor's level, but you get what I mean. Like it's like, oh yeah, just like pick up the hammer and like just use it. So yeah. All right, is the sum this and this rational or irrational? This is going to be irrational. Okay, so looking at this one here, the reason why it's irrational, now this is like a lot of number sense, but square root of a non-perfect square like 2 is not a perfect square, is irrational. There's no pattern to it. So if we just add 4.2, so now I do plus 4.2. This is a terminating decimal, so it's only going to change up to the 10th place. So this will make 5.6 blah, blah, blah. But you see everything else is still wacky afterwards. Now, don't say that on the Regents. But here, Patrick is correct. Okay, state whether Patrick is correct. We'll just say Patrick is correct. All right, and the reason, because the sum of a rational and an irrational is irrational. Okay, so this number here is rational, and this one is irrational. So because the sum of an irrational number we'll say the square root 2. Sum of an irrational number and a rational number which is the 4.2 is irrational. Okay, that's it. So yeah, square root of a non-perfect square is irrational. All right, percents. So here, let's see what we got. Newspaper, blah, 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 surveyed the student body for an article about club membership. The table below shows the number of students in each grade level who belong to one or more clubs. If there are 180 students in 9th grade, so this is the total, what percentage of 9th graders belong to more than one club? So 9th graders tells us to look here. Okay, and more than one club tells us 2 or 3 or more clubs. So the concept for percents is do part over whole. Okay, so the part, we have 33. So let's try that again. So we have 33 plus 12 is the part. Over the whole, there are 180 students. Now you might say, wait a minute, I added all of these and I didn't get 180. That's because some students are in 0 clubs. Okay, and we get 45 over 180. And this will give you 0.25. But now as a percent, if you want to turn a decimal to a percent, just do times 100. And then that's your percent. Okay, so this works out to 25%. All right, cool. All right, so this one, a lot of writing. All right, this Regents was very writing heavy. I feel like I should have picked something else. Okay, so a function is shown in the table. If included in the table, which ordered pair would result in a relation that is no longer a function? So here, just think of the repeating x value. Okay, so we're going to pick the point that the x value is already there. So notice that this one, there already is a -4. So the reason why you can't have repeating x values with different y values is if I were to plot both of these, -4, 2, yeah, this pen is possessed. I don't know what's going on these days. This program seemed to have upgraded. Like, it definitely got better, but I don't know, it's still annoying me. And then -4, -1. Like, when I was streaming for AP Calculus, it was like every like 10 seconds or 20 seconds, this thing would glitch. I was like, oh no. But it seems to be getting better. All right, so here, if I do the vertical line test, if I have 2 points with the same x value, then the 2 points are going to fail the vertical line test, and this would no longer be a function. All right, so now we just have to write a sentence. This is like my least favorite part, but it needs to be done. So if -4, 1 is included, I'll just like abbreviate. I'm not going to say included in the table, just at the same time. If -4, 1 is included, the relation would no longer be a function. But we need a reason. We have to explain. That means we need a because. The relation, move that over. Okay, so the relation would no longer be a function. And the reason, so now we're going to say because this is our explain point. Because x equals -4 would map to two different y values. Okay, which is not good. We can't have the same x go to two different y's. All right, cool. All right, so this one, polynomial operations. This one's like somewhat straightforward. Subtract this though from this. So here you have to know to flip. When they say subtract from, this is like, be careful. This is tricky. Okay, so just watch out with that one. So we're doing 3x squared plus 8x minus 7, but then minus parentheses. Save the day. Please write parentheses. And when you subtract, I like to do this vertically. So 3x squared plus 8x minus 7. And you distribute the negative all the way through. The operation changes to addition, and you change the sign of every number on the inside. So we have minus 5x squared minus 2x, and then plus 11. And here we have 3 minus 5 is -2, and then x squared. 8 minus 2 is 6. And -7 plus 11 is 4. So writing it vertically helps. All right. Cool. How much is the curve? I guess we'll find out. If it's anything like the last Regents, then it's like 13 or 14 multiple choice seals it. But yeah. Oh, thank you so much for the tip. I really do appreciate you all. I mean, let me stop for a second and say like 3,000 of you stopping by. It's just so awesome. I really like just, yeah, have to show a little gratitude here. Like just thank you for being a part of this, because 3,000 people is like the size of the school I currently work at. So that's just, I don't know. I can't believe like we're at this level, but you all make it like fun and exciting. Like even though I'm just like me talking to a screen right now, it's like cool seeing the chat light up, and yeah. All right. So thank you for being a part of this. And if you haven't subscribed yet, please consider subscribing and help me grow this channel. My goal is to just, well, I just want to keep putting out quality content. I'm happy with how many subscribers I have. Once again, I'm shocked that it even, that it got this far. But the name of the game is like, keep making, the videos and try to improve them, and the people will come. So, but thank you for being here. All right. And if you take geometry, algebra 2, I'll just keep doing these live streams because I do enjoy them. Oh, there are graphs coming up. There's going to be a graph of a piecewise, which I know people don't like. So that's why, yeah, this will be good. Solve algebraically for x. So let's say you're like, no, thank you. All right. If you are like, no, thank you. Oh, wow, Lenora, thank you so much. I appreciate, yeah, that's so generous. Thank you. How nice. Once again, I'm just flattered. Yeah, $20. That's yeah, I see people in the chat like, whoa. Yeah, thank you so much. All right. So let's say you're like, this is a thing I think a lot of students go into the Regents not knowing, is they think like, oh no, I only want to pass with the multiple choice. They're like, I'm not doing anything in the free response. But look, if you don't do this algebraically, let's say you just go like this. You go here, and then the right side is 7. And you press graph. And you trace both of those intersection points. You do second trace 5. And you just go like this. Enter, enter, enter. And you get -0.5. And you do that for the other one. I want to point something out here. So let's just see. Does it? Let me just see which. This is question 29. So I just got to do a little scrolling because I have the rubric in front of me. And I want to talk about how they actually grade these Regents. But let's say like you basically just do this a different way. Like you show like no work, you only write the answers. You're gonna get 1 point just for doing that. All right. I guess I did close out the rubrics, but you'll get 1 point for doing that. But if you want full credit, then yeah, you should know how to do the algebra, which I'll show now. Okay, so here, 4x squared minus 12x minus 7 equals 0. So this formula they give you, the quadratic formula, you can factor this by grouping, but I already showed how to do that in the multiple choice, so I'm going to show this method. So here, a equals 4, b equals negative 12, c equals negative 7. And we're going to write down in the formula x equals. If b is negative, don't be like, oh, cool, they already wrote it for me. Like, no, negative 12 becomes positive 12. Okay. So this one here, yeah, that's how it goes. Okay, so that's how it would start off. All right, and I'm sorry, I'm just making sure my chat is visible. I have 2 monitors. I just want to make sure I'm like following the best I can. So plus or minus, and now b squared, I have negative 12 squared minus 4 times a is 4, c is negative 7, and then over 2 times a is 4. And now watch, calculator time. So for this one, then I just go alpha y equals enter, and I have 12 plus. Oh yeah, I'm sorry. Yeah, so I'm sorry. Yeah, I already. It's, you know what? At stream pain clips, it's muscle memory. So yeah, alpha x. I've said alpha y equals enter probably about 1,000 times in the last 2-3 years. That yeah, I just have to like unlearn it. It's like part of my like. It's like I'm not even thinking at this point. After teaching all day, and then like I come home. Yeah, look, the reason I do these streams so late is, you know, I'm a dad, and me and my wife work staggered hours, so like I feed my kids, put them to bed, all that stuff. My kids are little, so like that's why I start this late, because I just like I have to do this once my kids fall asleep. That's really the time I have to do YouTube these days. So just very, very busy. So it's plus or minus, but if I do the plus first, I get 7/2. All right. Realistically, the calculator is going to be in decimal, not auto. So I'll get a decimal, which is also fine. Like if I go this, I'll get 3.5. And then when I want the other one, the minus, I go left. All right, and I change it to a minus, and I get this one. All right, so then here, like once I get to this, I have, okay, x equals 3.5. And x equals negative 0.5. All right, that's it. Oh yeah, I think they make you write in pen in the part 2, 3, 4, but graphs could go in pencil. Yeah. At this point in the game, tips for tomorrow, just like study what you can from now till like you go to sleep. But then try not to focus too much on the outcome. Just focus on like going into competition mode and like just do the math until they're like, all right, pens, pencils down, like, and don't quit. One of my fun fact, I do outside of being a math teacher, I also train Brazilian Jiu-Jitsu. I'm a black belt in Brazilian Jiu-Jitsu, and I've done competitions too. And when you compete, you're nervous. A lot of the guys, like, you know, and girls like waiting to go out there are nervous. And what winds up happening though is you just have to make peace with like, all right, well, this is it. I'm not gonna learn a new move. I'm not gonna like all of a sudden be twice as strong or fast. This is what I got. And then you get on the mat and you slap hands and you're like, all right, let's just see where this goes. And you just go for it. Right. And you know, if you let your mind take over, like, oh no, I'm so scared, I'm cooked, like I'm gonna fail, you're not gonna bring your best performance. Like you just want to go out there and be like, all right, well, I put the time in, I did what I could. You know, if you didn't practice at all, then like, yeah, I guess you could be more nervous. But like, if you practiced a lot, just like go out there and do your best. And you're gonna be nervous walking to the test. Like everybody is like a little bit anxious and on edge. But like once you sit down, like just be like, all right, come on, let's bring this. Me personally, I know I used to like listen to music. I wouldn't look at any math like 45 minutes before the test. I would just like get in the zone and get myself like ready to go. Some people study up to the second the test comes out, but yeah, that wasn't my style. So you find your own style. But good luck. I hope you all do well. All right. But I'm proud of you for being on here and putting in the time. Some people might just be playing video games right now or watching a movie or a show. So, all right. Piecewise functions. Oh no. For this one, what you have to pay attention to is this. Now, the most common mistake, I'm going to say don't. So don't go like this. You're like, all right, absolute value. And they're like 1, 2, 3, 4. They're like, and y equals 4. And they just graph a system of equations. And it's like, no, don't do that. Okay, that's bad. This is not a system of equations. This is a piecewise function. So this here from -3 to 1. So let's see, -3 to 1. That tells you where you're allowed to graph absolute value x. So if you're like, I'm just going to go as far as I want, they're like, no, 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 no. You are not allowed to graph it outside of the yellow, okay? You're only graphing this portion of the graph. So that's the concept here that you need. That this tells you where to graph the thing to the left. So absolute value x looks like this, and we are only allowed to graph it from -3 to 1. Now the catch also, see how it's just less than 1? That means it's going to be open here and it's going to be closed over here. So that's like a small detail that gets people. All right, like they just go like this and they're like, all right, I did it. I did the thing. But like, no, this one is open. So you put an open circle there just to show that it's open. Okay, and then y equals 4 is a horizontal line. And this one is happening, we pay attention here, from 1 to 8. So 1, and then 2, 3, 4, 5, 6, 7, 8 is happening here. Okay, so 1, 2, 3, 4. And I just draw my horizontal line. If you forget what these things look like, you're like, oh, what does absolute value x look like? What does y equals 4 look like? Then all you got to do is just go to the calculator and just type in. So like math, right, ABS, x, and then like y equals 4. And you're like, oh, it's the v in the horizontal line. But remember, you were only graphing it on that space. Cannot, like that's the property line to worry about. Okay? All right. Your teacher said not to just circle answers on the Regents. Well, I mean, if you just write your answer clearly, like that's fine. Just don't write down like multiple answers because then they got to mark you wrong. But I don't know. I feel like students have circled their answers in the past. Did I circle my? Yeah, I circle my answers. So I don't know. Okay. So moving on. Yeah, I mean, I circle my answers. Every teacher will tell different things. I'm not gonna say like, oh, listen to me, not your. Just a different style. Everyone's got a different style of teaching. How do you know if it's open or closed? Good question. So the equal to. You see how there's like a 1 less than or equal to x? If it was this instead, so let's say the question changed to this, like just less than, then I would open both of them. Okay, if this was less than or equal to, then I color that one. All right, so like that's the equal to makes you color it. So I know there's a lot of math symbols to learn. All right, so a gardener is planting 2 types of trees. Oh, this one's got a nice trap. Tell me if you see the trap. Let me know. So type A is 3 feet tall and grows at a rate of 15 inches per year. And type B is 4 feet tall and grows at a rate of 10 inches per year. All right, where is the trap? All right, I don't know if you see it, but the trap is the units. So here, see how it's feet? And then they're talking about inches. So we would convert 3 feet is 36 inches. So this is 36 inches. And this one, if I want to write a formula, I'm thinking y equals mx plus b. Let me scroll up because I think people probably can't see this. So I got to convert to inches and I got to use this formula. So this is like the fixed amount or like the starting amount, and this is the rate. So instead of saying 3 plus, like don't say, I'm going to say don't. Don't say 3 plus 15x. All right, that would be wrong. Because the rate is in inches, you're going to write 36 is 3 feet, 36 inches, plus 15x, okay? Because it's growing 15 inches per year. So we're starting at 36 inches and going up 15 inches. We're going to see when is this equal to, and then 4 feet is times 12 inches over a foot is 48 inches. So the equation for type B, so our B equation is going to be 48 plus 10x. So now algebra skills, minus 36, because we're algebraically determining. This is gone. 15x equals 12 plus 10x. All right, now just a little more algebra. Minus 10x. And now 5x equals 12 and divide by 5. And if you type this in, this should give you 2.4. There it is. Solving for x. Alrighty. So moving on. Okay, so this one, write an exponential equation for the graph shown below. And then we have to explain how we determine the equation. Yeah, this test was kind of weird. They made you explain some weird stuff. So this one, you might be thinking like, how do I do that? Well, 2, 1 is this point. And then it looks like 4, 4 and 5, 8. Those are like well-defined points. And now calculator. So we go to the calculator, stats, edit. And I'm just going to write in the point 2, 1. Okay, so 2, 1, 4, 4, and 5, 8. Right, 5, 8. And now we want an exponential equation. So stats, calculate. Exponential regression is over here. Calculate, and there it is. Okay, so this one, let me just shrink this down. Yeah, this one is like pretty fair to get the points. Like just knowing the calculator. So this one here, the equation is y equals a is 0.25. And then b is 2, and it's going to the x. Explain how you determine the equation. So now I just got to narrate like what we did. So say like, oh, I found, or I'll say I used the exponential. I'll say I used the exponential regression on my calculator with the points. And now I'll just say the points that I use. So with the points, and we have 2, 1, 4, 4, and 5/8. Okay. So this is like a bit of a strange question, like, but yeah, this is the idea. The Regents is new. It's hard to say. I mean, I think the only thing that'll make it more challenging is it's so new, and like teachers are like preparing you for it, but because like we haven't had a lot of Regents to draw from, it's like kind of, I guess, harder in that sense. But I don't know. I guess I kind of just have to see it because like algebra, it's just like, oh yeah, just like do algebra. Um, so the general rule of thumb is like, I know you probably don't want to hear this the day before the test, but just get in the habit of practicing math like every day during the school year. Even in the summer, like, I mean, I know who's going to do math in the summer. It's hard to convince students to do that. But if you want to go next level, like you just have to be consistent. Okay. So just practice consistently is the way. Like the only reason why I'm sharp at math still is like I teach it 5 days a week during the school year. And then I do like YouTube planning on Tuesdays. I make all the Regents videos. So even though I don't teach algebra, I don't teach algebra 2, like I'm sharp with those Regents because I like stay active with it. I mean, yeah, teaching, I normally teach calculus BC and like you do a ton of algebra in that class. So like that helps. But I mean, I just practice a lot. If you fail, don't worry, you'll still be you. And I'm like, I guess, still proud of you that you came to a review. You just try again, you try another time and whatever. It's like, it's everyone's, that's the hard part is everyone's on a different path and you all have like different lessons to learn at this like current moment in life. So, wherever it takes you, then, it takes you. Um, oh, Stream Fame Clips, thank you for the comment. I'm honestly, I really want to do my best to just make, quality instruction for people because I know like sometimes it's hard. Like people might miss their teacher for like part of the year or something. And I just want to put as much quality stuff out there. I also started adding grades 3 through 8. So, if you have younger siblings, like to say, oh yeah, he has test videos for grades 3 through 8 as well. So I'm gonna do yeah, all of that. So, oh, what high school? I teach at Newdorp High School in Staten Island, New York. I mean, if you Google me hard enough, you'll find out. So, yeah, but Newdorp High School. Shout out to anybody from Newdorp. All right. So let's move on. So we have part 3. Jacob and Zachary go to the movie theater and purchase refreshments for their friends. All right, so this is a classic system of equations question. So popcorn and drinks. So Jacob spent 1825. You got 2 bags of popcorn and 3 drinks for himself. Well, that's interesting. 3 drinks? We just get 1, but whatever. So here, I'm going to say popcorn is X and drinks are Y, unless they tell you to use a different letter. So here, 2 bags of popcorn, we're going to say is 2X, plus 3 drinks is 3Y, equals 1825. Okay, so there it is. Zachary spends this much money on 4 bags of popcorn. That's 4X and 2 drinks. And this is 2750. So here, we're going to use these equations to determine and state the price of a bag of popcorn and the price of a drink to the nearest cent. So for this one, elimination is the way to go. And you could multiply this one by -2. Like I could do, times -2. And that'll make a -4x, which will cancel out a 4x. Or if you really want to be, slick, you could multiply this one by -half. That would be really cool. Because then you'll have 2x and -2x, also canceling. So that's up to you. Whatever makes you happier, that's the one you'll use. Okay, so let's use the fraction one. That one looks interesting. All right, and then we'll show how to check our work at the end. So we have this. Just clean that up a little. 4x plus 2y equals 2750. Yeah, this is, I don't know why this is freaking out. Oh, it's starting to do that thing that I talked about. I jinxed it. I said, oh yeah, it was not behaving for a while, but now it's, all right, well, whatever. Let's see. So plus 2750. And now from here, we are going to, let's say I multiply by negative half. So from this step, 2x plus 3y equals 1825 remains unchanged. And now this is negative 2x, because negative half times 4 is negative 2. Negative half times 2 is negative 1, so I get minus y equals. And now I'm going to get negative, and then half of this is like 1375, maybe? Let's see. 2750 divided by 2. Yeah, minus 1375. And now we combine these cancel, we get 2y equals, and now 1825 minus 1375 is 450. Okay, so divide by 2, and y equals 225. So that is the price of a drink. For the price of the popcorn, now you plug back in. And you could really plug into any one of them. I could say, let's say I take this one now, and I do 2x plus 3 times 225 equals 1825. And this will work out to what, 675 when we multiply? All right, now we'll just subtract those two. So 1825 minus 675, which we're going to do that in a moment. So minus 675 on both sides. And now we have 2x equals 1150. And now divide both sides. Yeah, I don't know. This is freaking out a little. Okay, dividing by 2 gives us x equals 575. All right, so we could just say here that popcorn is 575 and a drink is 225. If you really want to play it safe, what you could do is plug in for x and y into both equations just to make sure they check out. Right? If you have the time, like, check your work for sure. Like, it doesn't take crazy long to do that. So whatever, I'll lead by example. So if I say here 2 times, we said 575, and then plus 3 times 225 is 1825. And if we plug into the second one, we should get 2750. All right. Let's see. Question 34. All right, we're making good progress. So let's see here. Write the inequality represented by the graph. So this one, I'm thinking of, let me see here, y equals mx plus b. And remember, this is slope. And this is the y-intercept. The y-intercept is all the way down here at negative 1, 2, 3. So negative 3. And the slope, I could just count the rise over run. Slope is rise over run. Okay, so that's one of the ideas. Rise over run. And to get from one point to the next, I'm going up 2 over 1. Up 2 over 1. So the rise over run, m, is 2 over 1, which is equal to 2. And the b value is negative 3. The only catch here is that when we write the inequality represented by the graph, is we're going to say y, and then instead of saying equals 2x minus 3, we have a decision to make. Are we going to say greater than? So it's like either greater than or equal to, less than or equal to. Well, since we're shading above the line, it's going up like this, it's going to be greater than. Since the line is solid and it's not like a dashed line like this, that tells us the equal to is part of it. Okay, so this has to be a part of it. All right, so that is our inequality, y greater than or equal to 2x minus 3. Now, the next thing they want us to do is on the same set of axes, graph this inequality. So this one here, I could just go minus x on both sides. And now I'm going to have 2y is less than negative x plus 4. And then I divide everything by 2. So the y is less than negative half x plus 2. Okay, so now same idea, slope, y-intercept. My y-intercept is 2, and my slope is negative half. So I'm going down 1 to the right 2. Down 1 to the right 2. Up 1 to the left 2. Okay, and I have my straight line. And now from here, I connect everything with a dotted line. The reason why I'm going dotted is in this situation here, it's just less than. Okay, so just less than means it's a dotted line. Now I'm going to shade under like this. On the new Regents, they usually make you label the solution set S. Remember, the solution set is where the shaded parts overlap. So make a nice bold S on the new Regents. And also, sneaky detail is make sure you label one of these. Like you could say this one is x plus 2y less than 4. Okay, you only have to label one. If you label both, that's fine. Like you can call this y greater than or equal to 2x minus 3, but whatever. Just labeling one is fine. And now they're telling us the two inequalities graphed on the set of axes form a system. Oscar thinks the point 2,1 is a solution. Determine and state whether you agree with Oscar. Explain your reasoning. So 2,1, notice, is located here at the point of intersection. This is not a solution because the purple line is dotted. So it's not a solution to the purple. Okay. So here, determine and state whether you agree with Oscar. I would say here, I disagree with Oscar. And why? Because I disagree with Oscar because 2,1 does not satisfy x plus 2y less than 4. Okay. And if I just want to really be safe here, I'll verify. I'll say 2 plus 2 times y equals 1. See, I plug in x and y and ask myself, is this less than 4? This 2 plus 2 gives us 4 less than 4. And this is not true. All right, so that would get us full credit. Alrighty, so here we are. Let's see where we are at. All right, we're making good progress here. We're at question 35, and we're not even 2 hours in. All right, so nice progress. All right, so this one, correlation coefficient. What does it mean in the context of the problem? Blah, blah, blah. So this one, let's get the calculator going. Stats, edit. And now I'm just going to be typing for a little bit. All right, I'm actually going to shrink this back just so I could see like more values here. Okay, so this part is like not very exciting. You're just going to see me type a bit. 186, 181, 176, 149, 184, 190, 158, and 139. $495, $477, $425, $322. My mantra here is don't make a typo. I just really don't want to make a typo. That would be sad. All right, 370, 322. Okay. And now for this one, you want to make sure mode, your stats diagnostics is on. I'm pretty sure, yeah, that's the thing. Because if the stats diagnostics is off, it's not going to give you a correlation coefficient. So now I calculate the if I do a linear regression here, see how now I get my R value. Okay, before I only had A and B, the R was missing. Pretty sure it was. But turning the stats diagnostics on will bring up your correlation coefficient. I'm glad I remember that. I was putting a lot of faith in like me remembering all the Algebra 1 calculator shortcuts. But all right. So there it is. So if all you do is write the correlation coefficient, you get 2 out of 4. So here R, just say to the nearest hundredth is 0.94. All right, if you can't round, then like, sorry, but hundredth, remember it's tenths, hundredths, thousandths, then 10,000ths, and so on. To the right is a 2, so we round down to 0.94. Explain what the correlation coefficients suggest in the context of the problem. Well, this is a strong positive correlation. Okay, so where my head is going, that when we have a correlation coefficient, it goes from -1 to 0. The ends here are strong. So it's strongest at -1 and +1. At 0, like there's basically like no correlation. And then as we get closer to 0, the correlation gets weaker. But then what this suggests, if we wrote a linear regression, is that since this is a strong positive correlation, the linear equation here, like y equals 4.5875x plus this number, is a good fit for the data. Okay, so it just basically tells you like how good your line of best fit is. So when it's a strong positive or a strong negative, that means your line of best fit is legit. Like it's a good indicator. It's not a prediction. Remember, correlation does not imply causation, but it's like solid. Okay. So here, explain what the correlation coefficient suggests. So I'll say R equals 0.94 is a strong positive correlation. So then I'll say, therefore, oh, just, for higher math, when you get there one day, I promise you, therefore, I'm going to teach you something cool if you don't know this yet. You could abbreviate with 3 dots. I promise. Okay, so you could say, therefore, and let's see. Is a good fit for the data. And then I'll just say last. Okay, or even lastly. I don't know. It's not an English Regents. How about just say, we'll just write a sentence. We won't worry about. I don't know. Stephen King, I think at one point said like adverbs are just kind of like poor writing. He's not a fan of adverbs. Not that you should never use adverbs, but like, yeah. I don't know. We'll come up with a different way of phrasing it then. So therefore, the linear model is a good fit for the data, but in the context of the problem, I should mention hot dogs and calories per beef hot dog in milligrams. And here it's strong positive. So as the calories of the beef hot dog go up, so does the milligrams of sodium. Okay, it's a good fit for the data. And then we could say, and also as the calories per hot dog goes up, the milligrams of sodium, I'll just abbreviate milligrams. So the milligrams of sodium okay. Cool. Yeah, that one's like kind of annoying to write. But that's yeah, I know writing the essays, it's like kind of just it's like a lot. Ooh, this one. All right, this one's gonna make people sad. Completing the square on steroids. Okay, that's coming next. All right. So here, if you have your A value, so here I notice like, oh, A is less than 0. When A is less than 0, you have a sad parabola. And that means you have the vertex is a max. Okay, when A is greater than 0, your parabola smiles and you have a minimum at your vertex. Okay, so right away, I'm like, oh, A is negative, it's going to be a max. So given the function, state whether the vertex represents a max or a min. The vertex is a maximum. A lot of explaining. So the vertex is a maximum because A equals -1, which is less than 0. And therefore, 3 dots, the parabola opens downward. Okay, so the parabola all right, like that covers it. The vertex is a maximum because A equals -1, which is less than 0, and therefore the parabola opens downward, which makes the vertex the maximum. Cool. All right, now the fun part. Writing this in vertex form. So vertex form is when you have f of x equals a times x minus h squared plus k. Now, the thing is here, like if you don't do completing the square, you're going to get partial credit. So for this one, like if you have no idea what to do, then just use this formula. So what I mean by that, so let's see, y equals, and let's see, we have negative x squared. So this is, I don't like completing the square. Press graph, and you're like, oh no, I can't see it. So you can't see the vertex, then maybe you go to the table and see it. Seems like 425. But watch, I'm going to make the y maximum go above 25. Let's say I go up to 30. Now I see the vertex. And I'm going to hit second trace maximum because it's a high point. I get close. Hit enter. Once I go after the high point, enter, and then enter. See, it's 425. Texas, their instruments sometimes freak out, but 425 is fine. Okay, so 425. That is the vertex. So like this is the like the oh no, I'm scared way. This is like for partial credit. So for partial credit, if you're just like, okay, f of x equals a was -1. See how the coefficient of x squared, a is -1? So we could just start by writing -1 or just negative. And then x, wait, that was a long time ago. 425, that was the vertex. So hk, the vertex, is 4,25. So I could do x minus 4 squared and then plus 25. So like, yeah, if I just want partial credit, like I could just do that and say, all right, I know the formula and I'm just going to plug in and we're good. But if you're like, oh no, I want full credit, I want to get the 100, then yeah, you got to know how to complete the square. So completing the square in this case, I'm going to do my best to make it easy. But I'm going to take out a -1. Because completing the square works best when you have like a 1x squared in front. But if I factor out a -1, that's going to change the sign of everything. So I'm going to have minus 8x minus 9. And now here, the concept, remember, is take half of the b term and square it. So here, my b term is -8. I cut it in half, and I square it. -4 squared is 16. But watch, when you complete the square and it's not like solving for something, it's in function form, this is a little trick. I hope this doesn't ruin anyone's day. So look, I can't just do this. Like I'm going to leave a space and write my -9. So I'm just taking those and I'm spreading them apart. I want to add 16, but I can't just add 16 and hope no one notices. I can't just do plus 16 and be like, oh, no one saw that. Cool, now I can complete the square. No, if I'm going to add 16, I'm going to do something strange. I'm going to immediately do -16. The reason being, if I do plus 16 minus 16, I technically added 0. And if you add 0, it doesn't change anything. Okay, adding 0 does nothing to an expression. So yeah, you could add 0 whenever you want, right? So cool. Now look at this part. The stuff in yellow, I'm going to group this, and the stuff in green. These two belong together. So now watch this. The part in yellow, I'm looking for two numbers that have a sum. Let me change colors. So two numbers that have a sum of -8 and a product of 16. And if we work this out, here's the numbers coming up. We're going to have f of x equals -1. Now I'm going to write here. I could use parentheses or brackets. Yeah, maybe I'll use brackets because in a moment I'm going to write parentheses. So -4, -4. I'm going to have x minus 4 times x minus 4. That's the stuff in yellow. Okay, see how I just factored the yellow to get this? Now the stuff in green, I'm going to write over here. All I'm doing for this next part is -16 minus 9 is -25. Okay, so watch. This is going to simplify nicely. So -1 times x minus 4 squared minus 25. And now I distribute the negative, and we're done. F of x equals -1 times this is -x minus 4 squared. And then -1 times -25 is plus 25. All right, so this was like a hard question to get full credit. But all right. But they're telling you have to use completing the square. But remember, partial credit, like if you just want to find the vertex and then plug right into the formula, that's the easiest way. All right, but you're not going to get full credit. Yeah, so plus 16 minus 16. This is like this would be easier if it was like an equal sign over here, but yeah, this was a challenging one. All right. Oh, the final boss. We made it. I can't believe we're here. The last question. Thank you all for being a part of this. We actually made it here. All right. So New Clarendon Park, wherever that is undergoing renovations. One garden was square, blah, 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 blah. All right. So we have a garden. It's a square. Exciting. So the square, I'm going to call each side x. And the new garden, so the new one, will have an area that is 25% more. Okay. When you want a 25% increase, so here, you see how the area on the inside is x squared. If I want 25% more, then I want like x squared plus 25% is 0.25. Like I want x squared plus another 25% of x squared, which is 1 plus 0.25. Like I'm adding those two and getting 1.25x squared. Okay, so the new thing, is going to look something like this. Okay, because I read the rest of the question telling us that one side is doubled in length. So if I double this, I'm going to have 2x. And then the other side is decreased by 3 meters. So this would be x minus 3. So here we have to write an equation that could be used to determine the length of a side of the original square. So the area on the inside is this. And you have to know that area of a rectangle is length times width. Okay, so here I would just say that the area, and I'll write it over here, that 1.25 x squared is equal to 2x times x minus 3. And let me just shrink this all down, just so we have the space. And I'll shrink this down. Oops. Better. So I can put this all in one spot. All right, so there's our answer to the first part. This part is the most annoying. And there's, I read the model responses just to like see what kind of mistakes people make. And this kid is truly my hero. Like, this kid is going places in life. I think you all need to see this. So let me see which kid. Where'd it go? All right, so 6 out of 6. You write your sentence. But let me just see. 6 out of 6. Oh, here we go. Wait. Yeah, you ready? Sure, I think everybody needs to see this. This kid's my hero. Look at how they wrote this. They got a 5 out of 6 because they didn't feel like explaining everything they just did over here. They're like, it just does. So they got an incorrect explanation, but they did everything else right. So, like, I get it. Like, why get the 100 if they're just gonna? I mean, no. I mean, don't like purposely leave stuff out. But like, I don't know. When I had to do this, it was like another explanation. Like, this kid was probably just fried, or in your words, he was cooked. Actually, that doesn't apply here. Maybe, I don't know. I'm just gonna see. Yeah, someone said, "Hey, millennials, stick to millennial terms," but yeah, like it's annoying, but it's one test. You got 3 hours, so sit there and just write it, I guess. But yeah. So explain how our equation models the situation. Yeah, it just does. Like, I mean, come on. Like, I just did all the work. Like, now you want me to write a sentence to narrate my thoughts? Like, come on. So, yeah, that kid's that's my favorite answer a kid ever wrote so far. And I've been teaching 11 years. Like, that's just great. Because I get it. It's like, why? Why am I going to do all that? Like, it just, like, ugh. The kid probably did really well, too. So, let's see. Explain how your equation. All right. So, let me think. We got to write a sentence now. We got to write them a story. They want us to write another story. So, here we could say, let's see. The original garden is a square. So, each side of the square garden has side length x. All right. So, here we go. Side of the original garden can be modeled with x. Okay, so now we're just describing. We're like writing them a screenplay. Can be modeled with x. So the dimensions of the new garden can be modeled by, I'll just say, how about this? Instead of the dimensions, how about the length So the length and width. So we're specific, just in case they're sticklers. The length and width of the, let me just see, the new garden. Yeah, the new garden can be modeled by, yeah, this is annoying, this question. But it's the last question, right? Can be modeled by 2x and x minus 3. Since like one side is doubled. And the other is decreased by 3. Okay, so it's one side is doubled and the other is decreased by 3. I'm just like restating. That's why I don't like this question at all. The new area is 25% more. So 1.25 x squared can model the new area. Therefore, our equation is good. Okay, so therefore our equation is valid. Okay, cool. Oh wow, that was terrible. Yeah, like that's why it just works. That kid, it just does. That's my new slogan. Okay. So from here, determine the area. Now we got to solve this thing. So from this part, 1.25x squared equals, and we distribute. I'm going to get 2x squared and then minus 6x. So I can just go like this, minus 125x squared. Oh, the 3 dots? 3 dots means therefore. You don't have to use that symbol, but it's cool if you do. So 2 minus this is 0.75 x squared minus 6x. And from here, you could factor out an x. So 0 equals x times this. And if you set x equal to 0, you're going to reject this one. The reason being, then you won't have a garden, okay? Then the garden's invisible. So yeah, this one's out. But if you set this one equal to 0, okay, then you got 0.75x equals 6, and you divide by 0.75. So then x is equal to 6 divided by 3/4. I'm pretty sure it's 8. Yeah, is 8. But don't be so proud of yourself you solve for x that you forget to answer the question. The question is, what is the area in square meters of the new garden? So the new area, if you put your 8 here, this is 16. And then 8 minus 3 is 5. And 16 times 5 is 80. Okay. So we can even say like 1.25 times 8 squared. That's still going to give us 80. Okay. Now, one thing I would do to be safe is plug in over here to make sure it all checks out. So like if this is 8 by 8, the area is 64. And if you think about 64, 64 is like a bunch of 16s, right? So 25% of 64 is 16. If I do 64 plus 16, you see how it gives me 80. So like, yay, it works. All right. All right. So that's the 2015 January Regents. And now let me just see here. I'll talk to the chat. Let me just see. So how are we all doing here? Let's see. Crying? Oh no, crying. Don't cry. It's taking a break. Oh, you know, taking a break in the middle of the test is not a bad idea. That is not, I mean, look, don't take like a 1 hour break. Like that, you know, isn't cool. But yeah. So like taking a brain break could give you like a recharge. Like see, I brought my water and I stopped for a second. So oh, I'm happy to help. I'm really happy to help you all. Thank you for being a part of this. That there's 350 of you on right now is like still mind-blowing to me. That's yeah, that's like really just cool that yeah, you're all here right now. So thank you. But how come I've never yeah, it's how come you never seen I mean, this is like maybe it's a little outdated, but I mean it's technically algebra. I mean, you got a factor and all that. It's like application based. I mean, this is all fair game rectangles because you learn area of rectangles in like 4th grade. So, when am I doing a geometry live stream? Good question. Geometry I'm going to do the day before the geometry Regents. So, when is that? I have it on my calendar. Let me see. I'll just write New York Regents 2024. So geometry is on the 21st. So I'm doing it Thursday the 20th. Okay, at night. Try to do it earlier in the day if possible. I'll see. Maybe I could bump it back an hour. And then Algebra 2, I'm going to do Friday. So I'm going to do... Wait, I lied. Algebra 2, I guess I'll have to do Sunday as well. All right, I'll try to do that earlier. I played with the idea of doing physics because I taught physics for 2 years because there was like we didn't have physics teachers. But yeah, I don't know if I have it in me to do a physics one. I'd have to relearn it, but maybe we'll see. Living environment. I don't know anything about living environment. Like I feel bad at Mike Darwin. Like I feel like everybody would fail if I just started talking living environment. It would be like I'd have to just ask ChatGPT for like everything. Be like, all right, hang on a second. I'll just ChatGPT and try to sound smart. But no. Yeah, physics. I think I'd have to brush up, but I taught it for 2 years. So yeah, that's yeah. Good luck with the regions. So at Kev, good luck on your regions, everyone. No, not cooked. I remember just get yourselves like hyped up and do what you got to do. Um, it's a lot, but look, in a few hours it's over, right? You're gonna go to sleep. You're gonna take the regions, and it's over. So that's that. That's really all there is to it. Anything else? Will the 1B tomorrow be similar? I don't know. Maybe. Depends on their mood. I mean, hopefully there's some questions that are familiar. So I didn't just talk to you all for like 2 hours and tell you something completely different. Physics was so easy. I'm glad if you thought physics. I mean, physics people tend to complain about more. Like it's more abstract in a way. The math, like you have to be really good at math with physics. So algebra, it's worth your time to get good at algebra. Like honestly, like as a calculus teacher, I teach Calc BC, and your algebra skills are like probably the most important skills for calculus. Geometry, like you want to be a little bit good at geometry, like you want to be skilled at geometry and trig, but algebra, like for sure, is like the most important for calculus at least. So yeah, midnight motivation. No, I mean, look, I believe in you all. It's what's it called? It's it's a lot of pressure. I know getting ready for this thing, but yeah. Wait, I'm sorry. Is like uncle like the new? Is this like a new slang that's coming in? I guess I'll take it as a term of endearment, but it's just I'm trying to learn the new lingo as I read the chat. But yeah, good luck to everyone. Like that motivation, it's hard to hand off motivation. Like let me see. Um, which books have I read? This one is good. I should have had this ready, I guess. Huggins' book was pretty nice. Oh, there it is. I got this one. This one is pretty good. So these two. Sure, why not? Motivation. I gotta give credit where it's due. So we got Mr. Goggins, Mr. Arnold. What would they tell you to do? I don't know. I mean, just really just getting after it and not being afraid to fail. If you mess up, then you mess up. And big deal, like the main goal is the idea of Goggins would say there's no finish line, right? You just keep moving. Okay, you keep moving forward. And Arnold would say like something very similar, like just try to get after it, take chances, and not being afraid to fail. If tomorrow's not your day, then someday will be your day. So, just do your best. It's more of a marathon than it is a sprint. So just keep moving, and that's that. All right. So, oh, I'm happy to help. So, yeah, at Shelly, I'm happy to help. So, what does the curve mean when it comes to Regents? Well, it's just like they try to help people out, I guess, as much as they can. So if I pull up the one for this Regents that we just did, let's see, January 2015. I thought this was like a pretty hard Regents, though. I don't know. I guess it's like conversion chart. Let's see. So if I copy and paste this like onto the screen, let me see. Actually, let me go to a fresh page. And how about I just bring the whole thing over here? That's probably better. Yeah, so this one, like this is the curve they're talking about. That if we look to get a 65, so a 65 was a 30 out of 86. on this one. Okay, people might say, wait a minute, I thought it was only 14. Like they used to be less generous. They've gotten more generous over time. Okay, so yeah. Oh, thanks. Been watching videos for you. I appreciate you, Tyrone, watching. I'm happy to help. I really mean it, and I appreciate that you like the loyal, like you staying with me for the year. I'm just very happy that I'm able to help people. Yeah, it could be easier. Like that's why sometimes I pick a harder Regents, and it's like people are like, "Wow, it was so much easier." So yeah. All right, but I am gonna call it a day because I think if you all got a test at 9:15 in the morning, start winding down. Okay. But I'm just gonna wish you all, good luck. If you do need any help, with anything specific, like I have tons of stuff. Like I think I'm seeing people say like, oh, factoring. Um, honestly, like I could just like pull up like one of my videos that were like could have been probably more, um, like better advertised. Let me just see. Um, factoring. Let me just see the whole list. Factoring completely. That's algebra 2. Solving. Yeah, I mean, I have like a lot of. I have these videos here on quadratic equations. I guess. Yeah, like one like this. I guess. Oh, that has a decent amount of views. This one. I'll throw this in the chat just so I feel like I'm helping people. Like, oh, how do I factor? Like here, that's a decent factoring video. It has like 13,000-ish views. Like, oh wow, that one took off. Um, I have some other ones. Let me see. Factoring trick. No, that's not. Solving quadratics by factoring. Oh yeah, this one here. So for the people that are like, hey, factoring, um, then this one too. Okay, so for the factoring people, I hope those two help. Yeah, that's why like I'm glad I made a lot of I've made a lot of these. Yeah, double check your work for sure. You have a calculator, use it. Oh, the Regents? Yeah, geometry. What am I gonna do? Um Oh, you know what? What I'll do, so let me make a note that oh, at Ray, you're taking the Regents at Newdorp. Well, good luck. If I see you, I'll say hello, but they're probably not going to have me proctor because they don't have math people proctor just in case we start yelling at all. No, I wouldn't yell at all the answers anyway, but they usually don't have math people proctor. But yeah, thank you all. Good luck. And at the geometry question, like, oh, what Regents? I will update the geometry live stream, and I'll say like which one I'm doing. Okay. Um, oh, great. At Sophia, if I'm saying it right, but I appreciate the support. All right. Good luck, everybody. I'm wishing you all the best, and I'm proud of you for sticking it out and studying the night before. All right. Good luck. Wishing you all the best.